Hello. In today's video, we continue the architectural course with the fourth part, where we will focus on documentation. Below, we will learn about creating sections, elevations, and callout, as well as how to modify their display. Before we dive into the practical part, let's clarify what a section is in architecture. A section is a view that is created by cutting through a building in an imaginary way. It illustrates the vertical dimensions of the building and architectural elements, and their layering, that cannot be shown on the floor plan. The section is a new view derived from the building model and will remain linked with it. The program creates the section as a new 3D view, perpendicular to the section plane. We can create as many sections as needed for the building. The section view is entirely dynamic and will reflect changes made to the building model. We can work on the section view, just like the floor plan. We can select and modify specific architectural elements. The section line will appear on the floor plan, where we created it, but we can choose to display it on all levels. The section line is represented by a dashed line with letters and arrows in the end, indicating the direction of the section. The default symbol can be replaced with a custom one. If we move, rotate, or mirror the section line's position, the section view will update instantly on the plan. The section view allows us to represent elements with or without material hatching, using thin or thick contour lines. When creating the section line, we can set its depth and width. Resizing the cutting region allows us to control what appears in the section view. Once we have created sections, we can manage them in the Project Navigator. We'll see how to do that during the workshop. It's useful to know that when creating the section line, it will automatically generate a name for it, and we can easily find it in the Project Navigator. For example, Section A, Section BB, and so on. Each section will have its 3D view, avoiding multiple 3D views associated with a single section. If a 3D view associated with a section is turned off, a warning message will appear when trying to create a new 3D view for that section. We can check this in the Project Navigator. If a visible 3D view is associated with an existing section, we can update it using the View Create Update command. Sections and elevations can be created in two ways, as raster image or vector drawing. Raster images are more efficient and versatile, while vector drawing offer higher precision. Both sections and elevations can include dimensions, annotations, level lines, tags, grid lines, and various other elements. Let's explore the difference between raster and vector drawing. Raster images are ideal for accelerating the design process and producing informative and diverse views. A raster view can be generated in seconds. The raster view is easily customizable, allowing for various visual representations such as hidden line, X-ray, or color display. The quality and size of the raster image depend on its resolution, with higher resolutions offering better quality. The drawback is that raster images cannot be scaled to a larger physical size without loss of quality. Zooming in may cause the image to become blurry. Raster images cannot be edited as vector graphics, so they are recommended primarily for creating working documentation during the design phase. The advantage of vector graphics is precision. It consists of geometric primitives such as angles, lines, and curves. It preserves its appearance regardless of size, and can be printed without quality loss. Vector drawings are freely editable. The drawback is that computation time for vector drawings is significantly slower than for raster images, so it is best suited for creating final documentation. Now, let's see how we can display them. As I mentioned before, we can find the completed sections and elevations in the Project Navigator after discussing their definitions. Let's get to work. We've already completed the entire building in previous workshops, so we can now start creating the documentation. As mentioned, we'll start by creating sections, elevations, and callout for this completed building. We'll work on the floor plan for now. We will access the sections and elevations here, under the documentation menu. Let's take a look. I click on the section, and I will choose the first command, which is the section settings, where we get the section settings dialog. The section settings dialog is divided into three main groups: 2D display, 3D display, and marker properties. These properties can also be collapsed or expanded. Let's go through the properties to see what we can set. First, we will set up the 2D representation. These are the properties that we will see on the floor plan. So, we can set which layer the section line will be placed on. It should be on the text layer. I can set the color and line type, which will be a dashed, dotted line by default. Also, I will set the line weight to 0.1 mm. I can set the draw order, as well as the letter, and its text style. It should be A and Arial 200. Furthermore, I can set whether the markers should be visible or hidden, and on which level the section line should be visible on the floor plans. If I turn this off, the section line will only be visible on the level where I created the section. If it is checked, then it will be visible on all levels. Now, we are done with the 2D representation. Let's move on to setting up the 3D representation. Here, I can set the display mode, whether to create a raster or vector drawing. First, I will create a raster image section. I will choose the consistent color with wireframe option for the display. I can set the upper and lower limits of the section, relative to 0. I can also determine the depth of the section in meters, and define the color for the elements behind it. I can enable the display of grid lines, and choose whether the section should end at the edges of the section line. This option could be useful when there are other buildings in the vicinity, but I only need to create a section for the current building. I can display contour lines on the view, and adjust the style of both the contour lines and their text. I can also modify whether the program should hatch the section. We can hide the objects, since architectural sections do not require objects. This option is more relevant for vector drawings, because it takes more time for the program to calculate the vector graphics, if it includes objects. Now we are done with the settings for the 3D representation. Next, we can adjust the properties for the arrows and ends. By clicking here, I can change the symbol, as well as set the size. I can also specify the arrow's attributes, and adjust the thickness of the projection line. We have now covered all the settings. I will accept them by clicking OK. Let's create a horizontal raster section using the documentation, section command. I need to draw a horizontal line to indicate where I want to place this section. I want it to intersect the first flight of stairs. So, I start here and end it here. Then I need to specify the direction for creating the section. I will create it in a way that the stairs will be visible. The program will create the image section in a completely separate window. I can insert this window among the other windows, using the icon in the bottom left corner of the navigation bar. In this section, we can see the colors, textures, and contour lines that the program automatically generated. Now, let's create a vertical vector section. I will go back to the section settings, and instead of the image, I will choose the vector drawing, with a hidden line option. I accept the settings, and create the vertical vector section, using the section command. I will draw this through the stairs, by intersecting the two openings. In such cases, I can hold down the Shift key to ensure the section line remains vertical. I will specify the direction in which it should be created. Done. I will insert this window among the other windows. As mentioned before, the sections are linked to the model. This also applies to the section line. If any modifications are made, the section will also be updated. However, we can choose to disable the automatic update of the section when making modifications. This can speed up the work a bit. If the program always updates these modifications automatically, it can slow down our workflow. I will show you where we can disable this. In the settings, under the graphics section, we can find the option Keep Section Views of this project updated. Now, let's create a segmented section. To do this, I will go back to the floor plan. We can create a segmented section using the segmented section command, or we can modify an already created section. So, I select the section line, and by clicking on the line marker, I insert a node, for example, on this vertical line. Then, again, by clicking on the line marker, I choose Offset and draw it. For example, to this point. I accept it with Enter, and the program will ask if it should update the section. The segmented section is now created. Next, let's work on the longitudinal section. We can see that the various structures of the building have different hatching. The hatching on the walls is appropriate, but we will modify the hatching on the slabs. As I mentioned, we can work on the section, just like on the floor plan or 3D view. If I select an element, it shows that it is a slab, and I can use the pencil to modify its properties, just like on the floor plan. I will modify the layers of the slab. As we can see, it currently has a reinforced concrete material. We will edit this material, and attaching properties. If the reinforced concrete material is selected, I click on the gear icon, and choose the Edit Material command. Then the Hatch on Section option. This way, I can select a different hatching, instead of the Hatch 67. For example, reinforced concrete ISO, and accept it. Here, I can set the size and angle of the hatching. I set a 500 by 500 mm spacing, and length size, but leave the angle unchanged. I accept this and all the other windows, and the section will be updated. The hatching disappeared, so we need to rebuild the 3D model, using the hammer icon, and then we get the correct hatching. As we can see, not only this slab, but all the reinforced concrete slabs were modified, because I changed the default hatching and section property of the reinforced concrete slab. The next step is to create elevations. To do this, I will go back to the floor plan view. Now, I will select the elevation view, elevation settings command, and we will go through the parameters we can modify. Here, there are only two groups, 2D and 3D representation. Essentially, we can modify almost the same parameters as in the section view. For the layer, I will choose the text layer here as well. I won't change the color and line type this time, only the line weight to 0.1 mm, and the text style to Arial 200. For the 3D representation, here as well, I can choose between raster and vector representation, and the options are the same. Let's create an image elevation, and I'll keep the hidden line option. As I mentioned, we can set almost the same parameters here, as in the section view, so I won't go through them again. I accept it with OK, and now let's see how we can create elevations under the elevation view. We can create both automatic and custom elevations. Let's create the north elevation. The program has created it. I will insert it with this icon. I go back to the floor plan, create the west elevation, and place it here. Then, back to the floor plan, I create the south elevation. As we can see, it's effortless to create elevations for this building. We can also modify their representations afterward, by clicking on the elevation symbol. If we can't find the elevation symbol, we can easily locate it, by clicking the blue area above the window, and selecting the Show on the Floor Plan command. The program will then show us which elevation it is. I will modify the representation of the west elevation. I click on the pencil, and change the display type to consistent color with wireframe. I accept it. The program will ask if it should update the drawing. Yes. If we look at the west elevation, it is now created with colored representation. We can see that the level lines include the basement level, but this building doesn't have a basement at all. I could delete these lines one by one, but if I remove the basement level and the level manager in the early stages of the project, these lines won't be generated. So, I go back to the floor plan, and click on the level manager. Here, I can find the current levels, and by clicking on the basement level, and the red X, I will be able to delete it. The program warns us that deleting is irreversible, so it's important to be careful when deleting levels, to avoid removing a level that we might need later. Yes, I want to delete it now. The program recalculates the levels, and I accept it by clicking OK. Now, let's check the sections and elevations in the Project Navigator. We will find them here, and by right-clicking on the elevations, and selecting Update, the program updates them. Let's take a look at one of the elevations, and we can see that the unnecessary basement level line has disappeared. Now, let's delete the south elevation, for example. To do this, I will go back to the floor plan, and delete the symbol of the south elevation, using the Delete button. The program will warn us that I'm trying to delete a drawing from the project, and asks for confirmation. I click Yes. The south elevation is removed from here. Now, using the icon on the navigator, let's organize the windows. Let's recreate the south elevation. However, this time, I will choose the vectorial drawing mode, instead of the image representation in the elevation settings, and will keep it as hidden line representation. I will create the south elevation, using the elevation, south elevation command. Let's see how we can create technical shading. In the side menu, under Shadowing and Shading, we will find the dialog, where we can set up the shadows and shades we want to create. I want to create shade contours and hatching, keep it as hidden line image, and create technical, elevation shadow. I can also specify where I want the contour to be placed. Let's place it on the text layer. I accept it by clicking OK, and the program starts calculating it. As this is a vectorial drawing, it took a bit longer to create, but it created the technical shading with hatching. Now, I'll show you how to create sun shading on an image elevation. For this, I'll use the west elevation, and we'll use the View, Shadow, Shadow On, Off command to create it. We can also visualize this shadow in another time of day by selecting the Sun and Shadow Simulation command. By adjusting the sliders and using the sun controls, I'll be able to modify its direction. Okay, I accept it. Now it's done, and as we saw, the image elevation got shaded immediately, while the vectorial view needed some time for the program to create it. The last topic we'll cover is how to create callouts. For this, I'll use the longitudinal DD section, and we'll create the detailed drawing here. We'll find the callout under the documentation, callout command. We can draw it with a rectangle or a polyline, indicating on which node we want to work. But first, let's check the settings. We can set the 2D representation mode here, which layer it should be on, let it be the text layer too. We can set its color, line type, and line thickness. And we can also change the symbol. Let's keep it as an oval. The last setting is whether it should be printable. I accept it by clicking OK. Now, I'll draw the callout. So, I'll use the callout command and choose the rectangle tool. I'll just draw a rectangle here, and then place its symbol. The program created a completely separate node in a separate window. So, I'll put it here, among the windows. By the way, this maintains a live connection with the original content, but in the 2023 version of the program, we have the option to replace the content of the callout with a PNG or DWG file. I'll now demonstrate it. I click on the callout, choose the callout content command from the local menu, and I choose Import Raster Image. I'll find the PNG file in the ARCHLine.XP Draw folder on my computer in the Section folder. I accept it by clicking OK, and the program loads it. Let's also see how we can modify the structure of the slab. For this, I'll go back to the longitudinal section and work there. We'll modify the structure of the slab by clicking on it, then choosing the pencil and selecting the Slab Layers command. We've seen this dialog before, but we only modified the hatching of the concrete floor. Now, we'll create a new layer by clicking the plus button and change its thickness. The upper layer will be 100 mm. This will be a lightweight concrete, and the lower layer will be a 200 mm reinforced concrete. I'll also change the material of the upper layer to a different concrete material. Let it be the prefab concrete. We'll also check its hatching. So, I go back to the material. I select it, then, I click on the gear icon, and I choose the Edit Material command. In the hatching, I'll change the concrete ISO 1. I accept it with OK. The row and column size are correct, and the 45-degree angle is also fine. I accept everything with OK in the windows. The program updated the section, but the hatching disappeared, so we need to rebuild the 3D model with the hammer. Thus, we got the correct hatching. However, as we can see, the opening above the stairs has disappeared, so we need to recreate it. I go back to the floor plan view and select the slab. If I can't find the slab at the outer edge of the walls here, then I'll search for it in the drop-down list. From its local menu, I will choose the Create Hole option, and then draw it with a rectangle. I exit the command by pressing Enter, and I go back to the section view, and I rebuild the 3D model again. This way, the complete slab opening is also created. The last topic will be about how to modify the connection between the walls and the slab. I would like the walls to be connected to the top of the load-bearing layer, So this is what we need to modify. We could do this individually, in the wall settings, specifying the base height to be the top of the load-bearing layer, and it's already set that way. However, this won't work correctly. So, let me show you how we can make the modification properly. We need to modify this in the Level Manager. I'll activate the floor plan first, and then by clicking on the Level Manager, I can set these heights. Currently, the finished floor level is set to 50 mm. I will change it to 0. The top of the load-bearing layer is at -100 mm, and the bottom of the load-bearing layer is at -300 mm. I accept the changes by clicking OK. Now, let's see what happens. The program will recalculate the levels. I'll go back to the longitudinal section, DD section, and we can see that the slab has moved lower. It moved down, because the base elevation was set to -100 mm, so now we need to readjust it to the correct height. If we click on the floor and go into the editing mode, we can see that the base offset is -100 mm. We can either change it to 0 or, if we go to the edit mode, modify it to the finished floor. Then, we accept it by clicking OK. Now, it's correct. However, we need to rebuild the model again to see the floor hatching. So, by doing a rebuild, we achieve the desired connection, with just a few clicks, without having to modify the properties of all the walls. So, we have completed creating the sections and elevations, as well as the callout, and we have also seen how to create layered floor structures. With that, we have reached the end of today's workshop. Thank you so much for joining me today. See you at the next workshop. Until then, have a great day. Goodbye.